Subscribe to Careerflite and press the bell icon to never miss our videos.
Good morning, students. Welcome you again to this geography classes. And we are going to start a new topic today. The name of the topic is structure and composition of the atmosphere. So before I start the topic, I would like to request you so that please share and subscribe the channel. And let's proceed with the topic today. Structure and composition of the atmosphere. Now, today we are going to start with atmosphere. Atmosphere is one of the realm of the Earth. There are three realms you can find in Earth: atmosphere, lithosphere, lithosphere, and hydrosphere. These are the three realms in the earth. So when these three realms, the place where you can find both these three realms, like this one, atmosphere, hydrosphere, and this one, lithosphere. This place is biosphere. So in biosphere, we can find all this hydrosphere, atmosphere, and lithosphere, and we can find abundance of life in the biosphere. So among these all these realms, today the most important realms that we're going to talk is atmosphere. Now, first of all, before starting with the atmosphere structure and composition of the atmosphere, we have to know what is atmosphere is actually. Atmosphere is air. That is the air that is surrounding our Earth. The envelope of air that is surrounding our Earth. This is the Earth, and it is surrounded by an envelope of air. This portion is atmosphere. That actually is a part of the Earth. Atmosphere is actually part of the Earth. Together, we call it earth including atmosphere. So what is atmosphere? It is the envelope of air that is surrounding us. Now how we can feel atmosphere? The presence of atmosphere is surrounded by us. We are surrounded by atmosphere. Now how we can feel the atmosphere? By movement of wind. When there will be movement of wind, movement of air is known as wind. When there will be movement of air from high pressure to low pressure, we can feel the air. Otherwise we cannot perceive the presence of air. Now again, what is the importance of this air? We can live without food and water for some time, but without air, we cannot live for a minute also. So that is why for the survival of all living organisms, including human beings, we need to know about the air, the composition of the air, how it is changing, and what are the steps we have to take to maintain the right proportion of these atmospheric particles. Now, First of first of all, you have to know up to where we can find air. The air is a composition of gases, dust particles, and water vapor. So when I talk about gases, we can find from the surface of the Earth up to 32 kilometer, up to 32 kilometer from the surface of the Earth. You can find 99% of the air by mass of air. So 99% of the mass of air, that is the weight of the air, we can find up to 32 kilometer. After 30 kilometer, starting from the surface only, the density keeps on decreasing. The density of the air keeps on decreasing starting from the surface of the earth. At the surface of the earth, the density is very high. Density is high. Density of the air molecules are high near the surface of the earth. As we keep on increasing the distance from the surface of the earth vertically, the density of the air molecules will keep on reducing, and after 32 kilometer, we cannot find enough enough of these gases. There will be gases, but the density will be very less. For example, you can find oxygen only up to 120 kilometer. Oxygen gases up to 120 kilometer, but the amount of oxygen drastically reduces from here to there. The approximate density of amount of oxygen here is 21%. So as you keep on moving towards the upper part vertically, it will keep on decreasing. So in the hilly areas, the plateau areas, mountainous areas, the amount of oxygen level is very low compared to the plain area. If you compare the plain area, the amount of oxygen at the hilly areas are very low, but still they can survive there because of the biological adaptation. They have more RBC. People in the mountainous areas, they have more RBC. RBC will capture this oxygen with our lungs, within our lungs, and it will be transferred to different parts of the body. So there is, because of biological adaptation in the hilly and mountainous area, though there is less amount of oxygen, still people can survive there. Now when I talk about the composition of gases, composition of this one, composition of gases, atmosphere actually, okay, composition of the atmosphere. Now what are the different composition of the atmosphere? We'll start from gases, then dust particles, and water vapor. Water vapor, they are the main constituent of the atmosphere. So the atmosphere, when I talk about the composition of the atmosphere, the main composition of the atmosphere can be grouped into three types: gases, dust particles, and water vapor. Now the most important part is gas. We can find different types of gases in our atmosphere. The most abundant gas is nitrogen. Right, it is nitrogen. 78.08% it is nitrogen. Then again, oxygen. 21% is oxygen. You can say 78% nitrogen, 21% oxygen. The third most abundant gas is argon. Argon is the third most abundant gas, 0.93 percentage. And the fourth most abundant gas, carbon dioxide. It is 0.036 percentage. So these are the composition of the air, gaseous molecules near the surface in the troposphere zone, near the surface of the earth. Near the surface of the earth, this is the composition of the gaseous molecules. The most abundant gas is nitrogen, 78%. Then second most abundant gas is oxygen, 21%. And third most abundant gas is argon. Okay, it's not carbon dioxide, it is argon, 0.93%. Then again carbon dioxide, 0.036%. So these are the main constituent, main major gases in the atmosphere. Now again, the gases can be of different types. Some of the gases are very much important. We call it life-saving gases. Life-saving gases. Some of the gases are called life-saving gases. For example, oxygen and carbon dioxide. So oxygen and carbon dioxide, they are life-saving gases. How oxygen? Because we breathe, we inhale oxygen. We need to inhale oxygen in every minute, every second. Every second we inhale oxygen. So it is very much important. If there is no oxygen, no living organism, no animals can survive. And carbon dioxide. Why carbon dioxide is a life-saving gases? Because carbon dioxide is trapped by plants. Plants use carbon dioxide. Now what they do? They use carbon dioxide, water, and nutrients to convert sunlight, photon sunlight into food, glucose or carbohydrate. Okay, these plants, what they do, they convert carbon dioxide into glucose, or you can say carbohydrate, in the presence of sunlight. In the presence of sunlight, they will use the sunlight, the photons of sunlight, along with the carbon dioxide and water. In the presence of carbon dioxide and water, they will produce glucose or carbohydrate, and that carbohydrate will be eaten by other animals. So that is how carbon dioxide is another life-saving gas. Now, plants, the byproduct, the process of this conversion of carbon dioxide and water in presence of sunlight is known as photosynthesis. This process is known as photosynthesis. Okay, they make carbohydrate through the process called photosynthesis, and the byproduct of this photosynthesis is oxygen. Byproduct. In the process of photosynthesis, they release oxygen molecules, oxygen gases. Again, these gases are, again, we can inhale. The animals can use the oxygen gases because of the process of photosynthesis. Now, if you talk about the gases, one more important life-saving gases is known as ozone. Ozone, formula is O3. Now, ozone. Ozone we generally find in the stratosphere. The what is ozone? Ozone. What is the job of ozone? It protect us. It protect the living organisms on the surface of the earth by absorbing the harmful ultraviolet radiation. The harmful from the sun, lots of radiation comes to the surface of the earth. That is ozone molecule that is present in between 10 to 50 kilometer from the surface of the earth. We can find ozone in between 10 to 50 kilometer from the surface of the earth. This layer, this ozone layer, what they do? They use the UV light, UV part of the radiation, ultraviolet part of the radiation. to carry on reactions. So they keep the UV engaged. This ozone molecules keep the UV engaged so that the UV, most of the UV cannot reach the surface of the earth. So it helps, it protect us, the animals, from the harmful UV rays. If the UV rays reaches the surface of the earth, it can cause us diseases like skin cancer, mutation, all these things. So that is the importance of ozone. And one more thing you have to remember about ozone is that the ozone that we find in this stratosphere, they are life saving, they protect us from UV. But the ozone that we find in the troposphere near the surface of the earth, okay, the ozone that we find from 10 to 50 kilometer, from the surface of the earth, 10 to 50 kilometer. Here, these ozones are very helpful to protect us from harmful UV rays. But the ozone that we find near the surface of the earth within this range, they are not good ozones. They actually cause global warming. They are one of the greenhouse gases. Ozone is one of the greenhouse gases when we find it near the surface of the earth. But when you find it in between 10 to 50 kilometer, they are life saving because they protect us from harmful UV rays. Now, while talking about the gases, one more important gases. We have talked about three important gases till now: oxygen, carbon dioxide, and ozone. About carbon dioxide, we have talked about how this carbon dioxide is utilized by plants in presence of water, sunlight to produce food for them. So, there is another importance of this carbon dioxide for our atmosphere. Why? Because the release of high amount of carbon dioxide to the atmosphere is responsible for global warming. We are talking about global warming nowadays. Global warming. Why global warming causes? From where global warming? What are the source of global warming? Mainly it is greenhouse gases. Greenhouse gases. Now what is greenhouse gases? Greenhouse gases are gases like carbon dioxide, nitrous oxide, ozone, CFC, chlorofluorocarbon, methane. These are greenhouse gases. But we have all these greenhouse gases and they are responsible for the warming of the earth. These gases actually what they do, they behave like greenhouse. The greenhouse that we can see in the cold countries. Actually, what is greenhouse? It is a glass chamber. Greenhouse is a glass chamber. Now, what is the job of glass chamber? In the glass chamber, it allows the insolation to come. Insolation from the sun. When I say insolation, it means incoming solar radiation. Now, when this insolation comes inside this glass chamber, they again reflect back from the glass chamber. After hitting the surface here, they will reflect back. And while going back, this reflected part of the radiation is known as terrestrial radiation. Incoming solar radiation or insolation, then outgoing is terrestrial radiation. But what they do, what the glass do, they trap a portion of the infrared rays. Infrared rays. So infrared rays in this insolation from the sun rays, one of the component of sun rays is infrared rays, and infrared rays is responsible for the warming. Okay, it warms. So these infrared rays mostly while they come inside the glass chamber, and while going back, this most of the infrared rays are trapped by the glass, by this chamber. So these glasses, the glasses in this chamber, glass chamber, they allow all the radiation to come, but they do not allow most of the infrared rays to go out the chamber. So what they do, the infrared, since the infrared rays are responsible for heating, infrared rays are responsible for heating. So inside the chamber, because of increase in the infrared radiation, they increase the temperature within the chamber. So in the cold countries, what they do, they use this extra increase in temperature within the glass to grow different types of crops, to grow different types of horticultural or other crops. That crops is not, that cannot be grown in the normal temperature. It will be around 22 degree, 3 degree, like that. So if you if you do it within the glass chamber, within a glass chamber, it will be, the temperature will be higher compared to the outside environment. So that is what this glass chamber do, and it is known as greenhouse. This kind of house is known as greenhouse. Now when you compare this model with the earth surface, now what is happening on the earth surface? This is the earth surface, suppose the surface of the earth. Now what is happening in the earth surface? Again, sunlight is coming in the form of insolation. Again, it will go back in the form of terrestrial radiation. Now, what does greenhouse gases do? Especially carbon dioxide and other gases like methane, CFC, all these gases. Now, what they do, they actually absorb this infrared portion. infrared radiation. These gases absorb the infrared radiation, and because of that, if first it absorbs it, then again reflect back the IR towards the surface of the Earth. First, these gases absorb the infrared portion from the terrestrial radiation. They absorb it, and what they do next, they release it. They emit it towards the surface of the Earth, and because of that, they increase the temperature of the Earth. Because of that, global warming takes place. So the only reason why global warming takes place, this is the reason: the infrared radiation that is absorbed by these greenhouse gases, and they are reflected back to the surface of the Earth. So the thing that was doing by this glass chamber, trapping of the heat, is being done here by the gases called greenhouse gases. So this effect is known as greenhouse effect. We're comparing this phenomenon with this glass chamber. The job that was done by glass is being done here by these greenhouse gases. So this is known as greenhouse effect. And carbon dioxide, we are mostly worried about carbon dioxide. There are other gases like CFC, chlorofluorocarbon, methane. They have more capacity to hold, to absorb more amount of infrared rays. Gases like methane, chlorofluorocarbon, and other fluorine, chlorine gases, they can absorb lots of carbon dioxide. Sorry, heat. They can trap lots of heat compared to carbon dioxide. But we are not worried about these other gases like methane. We are worried about them, but not as high as carbon dioxide. Why? Because the amount of carbon dioxide is increasing very fastly. The amount of carbon dioxide in the atmosphere is increasing day by day, and it is increasing at a very fast rate. Because why? Because we are burning fossil fuels. Fossil fuels. Now, what are fossil fuels? Fossil fuels are the fuels like coal and petroleum. Coal and petroleum, actually, they are undecomposed carbon. They are made by the, after a long time, after millions of years, because of the trapping of the plants and marine animals on the within the surface of the earth. Okay, and under after a long time, under high pressure and temperature, they got converted into oil and coal. And this oil and coal, actually, they are nothing but undecomposed carbon. They are undecomposed carbon. They are not decomposed. Other living organisms on the surface of the earth, when they die, they become decomposed. Okay, animals like us, human beings, or other organisms, or other plants, any other plants, when they die on the surface of the earth, they will be decomposed by bacteria. But these fossil fuels, they are undecomposed. They are trapped within this earth only. Since they are undecomposed, they have lots of carbon content. And while the decomposed material on the surface of the earth, they release the carbon in the soil, but they are not releasing. They have this high amount of carbon, undecomposed carbon, and when we burn it, when we burn this undecomposed carbon like coal and oil, it will be released to the atmosphere. Carbon will be released to the atmosphere. So carbon plus oxygen, it will become carbon dioxide. So the amount of carbon dioxide increasing day by day. Every day the amount of carbon dioxide is increasing at a very high rate, at a very faster rate. So since from where you use these fossil fuels, mostly in this vehicle, industrial use, all these things. So because of the burning of these fossil fuels, we are releasing lots of carbon dioxide to the atmosphere, and this carbon dioxide, it is increasing, it is behaving like greenhouse gases. That is why we are more worried about carbon dioxide, because the amount of carbon dioxide is increasing day by day. Every day we are releasing tons of million tons of carbon dioxide to the atmosphere, and they are causing harmful. They are causing global warming, and it is harmful for every life, both plant and animal. So these are the important gases. Now, when we talk about the next most important component of the earth, that will be water vapor. Now, what is water vapor? Water vapor is nothing but H2O molecule, water molecule only, but they are in the gaseous form. We can find water in the three states: liquid, gaseous, and solid. In solid, we call it ice. In gas, we call it water vapor, and in liquid, it is water only. So, water vapor in gaseous state. Gaseous state. Now, what is the job of water vapor? First of all, just know how much amount of water vapor is present in the atmosphere. So, the variation may be from 1% to 4%. 1% to 4%. We can find amount of water vapor in the atmosphere from 1% to 4%. That is the amount of water vapor that we have in our atmosphere. It can be at maximum 4%. It will be less than 1% in some other places. So where we can find more water vapor? Water vapor in which areas we can find more water vapor molecules in the gaseous state. So if you see the earth, the map of the earth, the globe of the earth, you can find the tropical areas. The tropical areas, it means the region between tropic of cancer and tropic of capricorn. The region between tropic of cancer and tropic of capricorn, in this region we can find lots of water vapor. Why? Because the temperature is high there, the insolation is high in this region. Because of high amount of insolation and temperature, the liquid water, they get evaporated because of latent heat of vaporization. They absorb the heat from the sun, and when the heat absorb the heat, they evaporate. These water molecules evaporate. So we can find more water vapor in this tropical area. But in the when we go to the cold areas, polar areas, the temperature is low there, and because of that there will be not enough evaporation. Not enough evaporation. So if there is not enough evaporation, we cannot find water vapor in a large quantity. So the quantity of water vapor in the polar area will be very less. The quantity of water vapor in the polar area or the cold countries, mid latitude countries, will be less compared to the tropical countries, because in tropical countries the amount of water vapor is high because of high evaporation. So it will be around 4% in the tropical area, and it will be less than 1% in the polar area. So that is the amount of water vapor that we can find in our atmosphere. Now what is the job of water vapor? What is the function of this water vapor? It absorb insolation. Water vapor absorb the insolation, sun of heat of the sun. So it helps in balancing the temperature on the surface of the earth. Water vapor is surrounding our earth. Okay, we can find water vapor around our earth. It is enveloping our earth, and this water vapor helps to maintain, to balance the temperature. Okay, it doesn't allow to cool down the earth up to a very low temperature, neither it allows to increase the temperature to a very high. So it balances the temperature by absorbing a quantity of heat from the insolation. So there is the importance of water vapor. The next important one is dust particle. Dust particles. Now, when I say dust particles, it doesn't only include the dust that we generally speak about, dust of this soil or sand, all these things. It also includes different small, very small solid particles like ash, soot, yeah, soot, then pollen, salt particles, then again small soil particles. Now, what happened to these dust particles? These are all dust particles. Now, what happened to them? They go to the upper part of the atmosphere through the convective current. Convective current. Now, convective current is a vertical movement of air. Convective, sorry, convective current. So, convective current is nothing but the vertical movement of air, and the horizontal movement of air is known as advective current. The horizontal movement of air is known as advective current, and the vertical movement of air is known as convective current. Because of the convective current, vertical movement of air, what is happening? These dust particles are being sent to the upper part of the troposphere. So this dust particle will go to the upper part of the atmosphere, and here this dust particle will behave like hygroscopic nuclei. They will behave like hygroscopic nuclei. Now, what is hygroscopic nuclei? Hygroscopic nuclei. Now, hygroscopic nuclei means they are the center. They are nucleus, small particles around which the water vapor that was present in the nearby the surface of the earth. Okay, once the water vapor reaches the upper part of the atmosphere, troposphere, that is near the tropopause zone, they'll become very cold. The temperature at the tropopause is very cold, and because of that, the water molecule will get condensed. They'll become water. From water vapor, they'll be converted into water and again ice particles. So this water, once the water vapor nearby the surface of the earth, they reaches the upper part of the atmosphere, troposphere. So they will become water because of the decrease in the temperature. As we increase the temperature, the amount of water vapor increases. As we decrease the temperature, the amount of liquid increases. So more, if we keep on decreasing the temperature, this liquid water will again get converted into solid ice. So this water droplets, these water droplets will surround this hygroscopic nuclei, these dust particles. The dust particles have the capability to absorb water molecules. So they will behave like hygroscopic nuclei. These water molecules will be absorbed around this dust particle. This is the hygroscopic nuclei, and around this hygroscopic nuclei, these water molecules will be absorbed, and they will form cloud. They'll form cloud, and because of that, once they cannot resist the when the weight of this cloud will increase, the air just present beneath this cloud cannot resist this stop these clouds because of the continuous gravitational pull towards the surface of the earth. Because of this gravitational force, the water molecules, droplets plus ice crystals, they will fall down in the on the surface of the earth in the form of precipitation like rainfall, snowfall, etc. So this is the importance of dust particles. Now we have talked about the composition of the atmosphere. Composition means the different composition, different constituents of the atmosphere. First we have talked about gases, then we have talked about water vapor, then next we talked about dust particles. Now in this next part we are going to talk about the structure of the atmosphere, the different structure, how we can categorize the atmosphere. We can find different layers. We can categorize the atmosphere into different layers based on the temperature and density. Based on the temperature, based on the temperature and density. Okay, based on the temperature and density, we can make different layers of the atmosphere that is present over the surface of the earth. This is the surface of the earth, and up to here atmosphere. Okay, this is the atmosphere. So we can categorize this atmosphere into different layers. We can divide it into different layers based on temperature, how much temperature each layer have, and how much density of air molecules each layers have. Okay, based on that, we can categorizing the atmosphere into five layers. There are five layers of the atmosphere. The first layer is this is a surface. The first layer is troposphere, and this one next one is stratosphere, stratosphere. Then mesosphere. The next layer is ionosphere or thermosphere, ionosphere or thermosphere, and the last one is exosphere. So these are the five layers. One, two, three, four, five. These are the five layers of the atmosphere. We have named them as starting from the surface of the earth as troposphere, then stratosphere, mesosphere, thermosphere or ionosphere, then exosphere. Now how we have categorized them based on density and temperature. Now we are going to see what is the changes in the temperature and density in the different layers. First of all, from the surface of the earth. Suppose this is the surface of the earth. From here, the first layer that will be troposphere. The troposphere we can find up in the this is the surface of the earth. So this is the first layer, troposphere. Now if you see the temperature here, so we can find a troposphere zone up to 18 kilometer in the equator. So this is the equator zone up to 18 kilometer. We can find in the equator, over the equator, and over the polar region it will be around 8 kilometer. Okay, the distance from the surface of the earth up to the highest portion of the troposphere, that is known as tropopause. This portion, the boundary is known as tropopause. Why tropopause? Because the temperature pause here. Okay, so you can find that height, the distance from the distance of this troposphere from the polar region is 8 kilometer, and the distance from the equator it is 18 kilometer. Why there is difference? Because we are categorizing these layers based on temperature, and the temperature, the convective current of that will bring the warm molecules air to the upper part. It will be up to a very high distance in the in this equatorial zone. In the equator, the temperature is very high, and near the polar area, the temperature is low. That's why it is less 8 kilometer near the polar area. Now, if you try to make a graph here, and if you categorize the different layers, we'll again redraw it. Suppose this is the surface of the earth, and this is the graph. We're trying to make a graph here. These are height. This line represents height, and this line represents temperature. Temperature. Suppose this is 20 degrees Celsius, 0, minus 20 degrees Celsius, minus 40 degrees Celsius, minus 60, minus 80, then minus 100 degrees Celsius. These are a temperature graph. This line represents temperature, and this line represents height. Okay. So up to where we can find this troposphere on an average, as we have seen, 18 kilometer in the equatorial zone and 8 kilometer in the polar zone. So if we take the average, 18 plus 8 divided by 2, it will be 13 kilometer. 13 kilometer here. 13 kilometer. So this zone is nothing but troposphere. This layer is troposphere. Okay, now what happens in troposphere? As we keep increasing the distance from the surface of the earth, as we keep on moving from the surface of the earth towards the upper part, the temperature keeps on decreasing. Suppose it is 20 degrees Celsius near the surface of the earth. Then as we keep on moving towards the upper part of the earth, the temperature will keep on decreasing. Okay, it will reach here. So here it is, see, you can see around minus 60 degrees Celsius. So as we have increased the height, this is the height graph. In the upper side, this is the height graph. As we are increasing the height, the temperature is decreasing. It was coming to 0 to minus 20, minus 40, and minus 16. Then again, the temperature at the polar region will be minus. The tropopause, this is the tropopause. The upper part is tropopause. Here, the temperature will be fixed. It won't change. There will be a pause in the temperature at the tropopause. At the tropopause, if you see the temperature at the polar area and at the equatorial area, equator. So the tropopause at the equator, the temperature will be minus 80 degrees Celsius, and at the polar it will be minus 45 degrees Celsius. Okay, there is a tropopause. Then again, the next layer that will come is stratosphere. 13 kilometer, from 13 to, or you can consider from 10 to 50 kilometer is stratosphere. This layer is stratosphere. This layer is stratosphere. Now, what we can see in stratosphere, we can find in stratosphere the molecule ozone. Okay, ozone, O3. Then the temperature will again keep on increasing here. It will again keep on increasing in stratosphere. The temperature will keep on increasing in the stratosphere. Now, the geographer are mostly concerned with these two layers, troposphere and stratosphere. The geographer mostly concerned about these two layers, troposphere and stratosphere. Why? All the climatic phenomenon, all the climatic phenomenon and biological activity takes place within the stratosphere. Biological activities, all the climatic phenomenon and biological activities that takes place within the troposphere only. So any kind of climatic phenomenon like tornadoes, thunderstorms, rainfall, cyclone, all these activities, formation of cloud, or everything you can find within the troposphere only. The next, biological activity. Since both lithosphere, atmosphere, and hydrosphere is available in this zone, you can find lots of biological organisms here. So you can find like climatic changes and biological activity in this troposphere. That's why this troposphere zone is very important for us. The next most is ozone. In the stratosphere we can find ozone. Okay, ozone, this ozone is helpful for us. Again, we have discussed before what is the importance of ozone. Ozone protect us from the harmful UV radiation. Then the next layer will be mesosphere. up to 80 kilometer. It will be mesosphere. Mesosphere, most of the meteorites that we see here, meteorites burning up their celestial bodies when they enter inside the surface of the Earth. When they enter into the atmosphere of the Earth, they burn up because of the friction of the air molecules with that celestial body, and because of that, we can see shooting star or meteorites. So you can find meteorites mostly in this. We can see in this layer only, mostly mesosphere. Then again, what happens here? Temperature keeps on decreasing here. Okay, temperature keeps on decreasing in the mesosphere. Actually, it decreases up to minus 100 degrees Celsius. Minus 100 degrees Celsius means it will reach up to here. Minus 100 degrees Celsius. Here, mesopoles. This zone is known as mesopoles. Mesopoles. The temperatures at my mesopoles is minus 100 degrees Celsius. Okay. Then again, the next important layer is thermosphere or ionosphere, up to 80, from 80 to 400 kilometer. Okay. The next layer is thermosphere or ionosphere. Thermosphere or ionosphere layer. Now, what is the importance of thermosphere and ionosphere? Any particle that is present in this layer will be in ionic form. Any particle that will be present in this layer will be in ionic form, either in positive charge or in negative charge. Okay, because of high amount of this insolation, the sunlight. Okay, they break down all these particles here into positive and negative ions. That's why it is also known as ionosphere. Again, the temperature increases here. The temperature increases here drastically. Okay, the thermosphere or ionosphere. Now, what is the importance function of the ionosphere? It helps to reflect the radio waves. the, it, this layer, thermosphere or ionosphere, it helps in the reflection of the radio waves. The radio waves that we send from the surface of the Earth, it will go there and it will be reflected by these ions. Then again, it will come back to the surface of the Earth. That's why it helps to in the transmission of radio signals. Then the last, above 400 kilometer, it is exosphere. Exosphere. Okay, we can find rarely any particles here. The density is very minimum here, and the exosphere is actually the boundary between the Earth atmosphere and the space. Exosphere is actually the boundary between the atmosphere of the Earth and the outer space. So we don't study more about the exosphere. It is just the boundary between the Earth atmosphere and the outer space. So this is all about the different layers of the atmosphere. We can see the different layers of atmosphere starting from troposphere. In the troposphere, why the troposphere is more important, most important for human beings, because all climatic phenomenon that is directly or indirectly related to our activities, our economic cultural activities, all the human activities are because of the climatic changes, climatic phenomenon, definition of climatic phenomenon and biological activity that takes place in this layer called troposphere. The next most important layer is stratosphere, from 13 to 50 kilometer. Okay, so in this layer what we can find ozone. So one thing you have to remember is that the ozone that we find here in the stratosphere is protecting us from harmful UV rays, but the ozone that we find here in the troposphere, it acts like greenhouse gases. All the greenhouse gases we find it here only in the troposphere. So when we find ozone in the troposphere, it will behave like greenhouse gases, so it will be harmful for us. Now here in mesosphere there is not enough much importance of the mesosphere. The next layer is thermosphere or ionosphere, from 80 kilometer to 400 kilometer. From 80 kilometer to 400 kilometer, this zone is thermosphere or ionosphere. Now what is again importance of this ionosphere and thermosphere? It helps to reflect the radio signals. And the last one is exosphere, that separate our earth atmosphere from the space. So in this class we have talked about the different composition and structure of the atmosphere. In the next few chapters we are going to deal with the different climatic phenomenon, budget of the heat budget of the earth, how much insolation comes, how much terrestrial radiation goes out, climatic phenomenon, the factors responsible for the distribution of temperature on the surface of the earth. All these things we are going to deal in the next few chapters. So this is all about the today's class. If you have liked this video, please share and subscribe the channel. Share the video and subscribe the channel. We'll see you again. Thank you very much.